The year was 1978. Inside General Motors headquarters, executives believed they had found the answer to America's biggest automotive problem. Not more horsepower, not bigger V8s, not another muscle car. Fuel economy. The oil crises of the 1970s had shaken the American auto industry to its core. Gas prices had surged. Customers who once bragged about quarter-mile times were suddenly asking how many miles they could squeeze from a gallon of fuel. Lines formed at gas stations. Some stretched for blocks. Tempers flared. Fistfights broke out over fuel. People waited hours just to fill their tanks. The American dream of unlimited driving was colliding with geopolitical reality. Politicians in Washington were demanding action. Regulations were coming. The corporate average fuel economy standards were looming on the horizon. Automakers would soon be forced by law to improve efficiency. Detroit was desperate. And that's when General Motors made one of the most controversial decisions in automotive history. They would build a diesel-powered American luxury car. On paper, it looked brilliant. In reality, it would become one of the biggest engineering disasters Detroit had ever created. An engine so controversial that it damaged the reputation of diesel passenger cars in America for decades. An engine that broke every rule and paid the price. Most people know the story as a simple failure, a bad engine, a bad idea, a corporate mistake, but the truth is far more complicated. Because the Oldsmobile Diesel V8 wasn't born from stupidity. It was born from pressure, massive pressure. Political pressure from Washington demanding better fuel economy standards. Financial pressure from shareholders watching profits evaporate. Competitive pressure from foreign manufacturers who seem to have cracked the code. Cultural pressure from customers who suddenly valued efficiency over performance. And what happened next changed the American automotive industry forever. To understand the disaster, you have to understand the world that created it. In the late 1960s, American automakers ruled the road. The muscle car era was in full swing. Chevrolet had its 396 and 454. Pontiac had the GTO. Ford had the Cobra Jet. Chrysler had the Hemi. Bigger was always better. More displacement meant more power. More power meant more sales. More sales meant bigger profits. Fuel was cheap, sometimes as low as 30 cents per gallon. In some markets, even cheaper. Nobody cared about efficiency. Nobody thought about conservation. The idea of fuel economy as a selling point was almost laughable. Engineers designed for performance. Marketing departments sold horsepower. Customers bought the biggest engines they could afford. The formula was simple, and it worked. American cars dominated American roads. Import market share was negligible. Detroit controlled nearly everything. Then everything changed. In October 1973, the OPEC oil embargo sent shockwaves across America. Arab oil-producing nations stopped shipping petroleum to the United States. The reason was political. The impact was economic. Fuel prices skyrocketed overnight. What cost 30 cents suddenly cost 60 cents, then 80 cents, then even higher. Gas stations ran dry. Some states implemented odd-even rationing based on license plate numbers. If your plate ended in an odd number, you could only buy fuel on odd-numbered days. Even numbers got even days. News broadcasts showed mile-long lines of cars waiting for fuel. Tempers boiled over. Violence erupted. Station owners posted limits, 5 gallons per customer, sometimes less. Customers began abandoning thirsty V8-powered cars. Dealerships couldn't give away big block muscle cars. The same Chevelle SS that had been a badge of honor suddenly became an expensive liability. Insurance was high, fuel costs were soaring, nobody wanted them anymore. Suddenly fuel economy mattered. It mattered more than anything, and foreign manufacturers were ready. Volkswagen diesels were gaining attention. Their Rabbit diesel became surprisingly popular. Toyota sedans were proving reliable and efficient. The Corolla became a bestseller. Datsun was building market share. Honda entered the American market with small, efficient cars. Mercedes-Benz diesel sedans were building reputations for durability and efficiency. Some diesel-powered Mercedes cars routinely exceeded 30 miles per gallon while running hundreds of thousands of miles. Taxi drivers in New York and Chicago swore by them. Fleet operators calculated the numbers and switched to diesels. Business executives began questioning why their American luxury cars couldn't deliver similar efficiency. GM executives saw an opportunity. If Americans wanted better fuel economy but still preferred large, comfortable cars, why not give them a diesel V8? The concept was simple: combine American size and comfort with European efficiency. Give customers the best of both worlds. The execution was not. In boardrooms, the logic seemed airtight. Mercedes proved diesel passenger cars could work. They had decades of experience. Their engines ran forever. American customers still wanted full-size sedans. The shift to smaller cars wasn't complete. Many buyers still demanded space and comfort. GM had manufacturing infrastructure already in place. Assembly lines existed. Supplier relationships were established. The math looked good. The timeline looked achievable. The profit projections looked even better. Wall Street analysts loved the idea. Shareholders approved, but engineers on the ground saw warning signs. They understood what management didn't. The project centered around Oldsmobile's proven 350 cubic inch V8. The gasoline version had already been in production for years. It was reliable and already integrated into GM's manufacturing system. Millions had been built. The architecture was understood. Assembly lines wouldn't need complete overhauls. Parts bins already existed. Suppliers already understood the architecture. Existing tooling could be modified rather than replaced. Management wanted speed. The competition wasn't slowing down. The government wasn't delaying regulations. Every month mattered. Developing an all-new diesel engine would take years and cost hundreds of millions of dollars. Testing alone could consume half a decade. Mercedes had spent decades refining their diesels. Tooling would require massive capital investment. New factories might be needed. Competition wasn't waiting. The government wasn't waiting. Customers weren't waiting. Converting an existing gasoline engine would be faster, cheaper, and easier. At least that's what the executives believed. The spreadsheets supported the decision. The timelines seemed reasonable. Many engineers weren't convinced, but their objections were noted and dismissed. Diesel engines operate under completely different conditions than gasoline engines. Instead of using spark plugs, diesel engines ignite fuel through compression. Air is compressed until it becomes hot enough to ignite fuel spontaneously. That requires enormous cylinder pressures, far greater than anything a typical gasoline engine experiences. The fundamental physics were different. The thermal loads were different. The mechanical stresses were different. The vibration characteristics were different. Taking a gasoline architecture and simply strengthening it was like trying to turn a racehorse into a workhorse by adding bigger horseshoes. The core DNA was wrong, but deadlines were set. Budgets were approved. Project managers established milestones. Engineers did what they were told. The Oldsmobile Diesel displaced 350 cubic inches, or 5.7 liters. Its bore measured 4.057 inches. Its stroke measured 3.385 inches. Compression ratio reached a staggering 22.51. For comparison, most gasoline V8s of the era operated between 8.51 and 9.51. Some emission-strangled engines ran even lower compression. That meant every combustion event inside the diesel generated tremendous force. Everything inside the engine had to survive punishment that gasoline engines never faced. Engineers strengthened the crankshaft. They reinforced the block. They redesigned the cylinder heads. They added stronger connecting rods. Main bearing caps received additional material. The valvetrain was completely reworked. Piston design changed dramatically to accommodate diesel combustion characteristics. The camshaft profile was specific to diesel operation. Glow plugs were added for cold starting. The fuel system was entirely new. A Stanodyne DB2 mechanical injection pump replaced the carburetor. Fuel injectors replaced spark plugs. The final engine produced approximately 120 horsepower and 220 pound-feet of torque. By muscle car standards, those numbers were pathetic. A 1970 Chevelle SS 454 produced over 450 horsepower in gross rating form. Even smog-choked late 70s gasoline V8s made more power. The performance was underwhelming. Acceleration was leisurely at best, but horsepower wasn't the goal. Fuel economy was, and initially the numbers looked promising. Many drivers reported fuel economy improvements approaching 30% compared to equivalent gasoline-powered cars. Some owners saw highway mileage climb past 28 miles per gallon. A few reported even higher numbers. In a 98 or Delta 88, those were revolutionary numbers. Cars weighing over 4,000 pounds getting nearly 30 miles per gallon seemed impossible. Large Oldsmobiles suddenly became far cheaper to operate. Diesel fuel was also cheaper than gasoline in many markets, sometimes 10 or 15 cents per gallon cheaper. The cost savings added up quickly. A typical owner might save $50 per month on fuel. Over a year, that was $600. In 1970s money, that mattered. Dealers loved it. Customers loved it. GM loved it. Marketing materials celebrated the breakthrough. Advertisements showed sophisticated buyers choosing efficiency without sacrifice. Television commercials emphasized savings and intelligence. Print ads featured testimonials from satisfied owners. Order books filled. Production ramped up. The diesel option spread across GM's lineup. Buick offered it in the LeSabre and Electra. Cadillac offered it in the sedan DeVille and Fleetwood. Chevrolet offered it in the Caprice and Impala. Pontiac got versions too. For a brief moment, it looked like the gamble had worked. Detroit had answered the import challenge. American ingenuity had prevailed. Then the failures started. At first, they appeared isolated. A blown head gasket here, a hard start complaint there, an occasional engine replacement. Nothing unusual. Every engine program has early issues. Bugs get worked out. Suppliers correct defects. Normal stuff. But soon dealerships across America began seeing the same pattern. Cars arriving on tow trucks, owners furious, engines failing at surprisingly low mileage. Some failures happened before the first oil change. Others occurred around 10 or 15,000 miles. Very few engines made it to 100,000 miles without major issues. Mechanics noticed coolant contamination, oil that looked like chocolate milk, loss of compression, warped cylinder heads, destroyed head gaskets, and the failures kept coming. Week after week, month after month. Service advisors started recognizing the symptoms immediately. White smoke from the exhaust, sweet smell of burning coolant, loss of power, hard starting, rough idle. The root cause wasn't one single defect. It was a perfect storm of engineering compromises. One of the most significant problems involved head bolt retention. Diesel combustion pressures were dramatically higher than those of the original gasoline engine. The block simply wasn't designed for those loads. Many engineers later argued that the design simply didn't provide enough clamping force to contain those pressures consistently over time. Every time a cylinder fired, immense force pushed against the cylinder head. Thousands of times every minute, hour after hour, day after day, month after month, the head bolts stretched, the gaskets compressed, sealing degraded. Eventually, gaskets began failing. Once they failed, coolant entered combustion chambers. Steam formed during combustion. Combustion gases entered the cooling system. Pressure built in the cooling system. Overheating followed. Then catastrophic damage. Cylinder heads cracked. Blocks warped. Entire engines seized. But that wasn't even the worst problem. The real disaster came from something almost nobody expected. Water. Not inside the engine, inside the fuel. Diesel fuel quality in America during the late 1970s was inconsistent. The infrastructure wasn't designed for widespread diesel passenger car use. Most diesel fuel went to trucks and heavy equipment. Quality control varied wildly. Unlike modern diesel systems, the Oldsmobile used a mechanical Stanadyne DB2 injection pump that relied heavily on clean fuel for lubrication and operation. The pump was precision equipment, tolerances measured in microns. Machining was incredibly precise. Any contamination spelled trouble. Many fueling stations had contamination problems. Underground storage tanks rusted. Water accumulated at the bottom. Condensation added more water. Fuel filters at stations weren't always maintained. Nobody inspected them regularly. Water entered fuel tanks. Corrosion developed inside injection pumps. Injection pumps failed. Injectors malfunctioned. When an injection pump failed, replacement costs were enormous, sometimes exceeding $1,000. In 1970s money, that was a substantial percentage of the car's entire value. Some repair bills exceeded $2,000. Starting became difficult. Engines cranked and cranked without firing. Cold weather made it worse. Diesel fuel gelling compounded problems in northern climates. Owners in Minnesota and Wisconsin suffered terribly. Owners accustomed to gasoline engines didn't understand the different maintenance requirements. Nobody told them about fuel additives. Nobody explained water separator maintenance. Nobody warned them about fuel quality issues. Performance suffered, power dropped, drivability deteriorated. Repair bills exploded, owners blamed the engine. Dealers blamed the fuel. GM blamed maintenance. Fuel companies blamed storage. Everyone pointed fingers. Nobody was happy. And then lawsuits began appearing. Thousands of owners reported similar failures. Patterns emerged. Class action attorneys saw opportunity. Consumer advocacy groups got involved. State attorneys general launched investigations. Consumer confidence collapsed. The media seized on the story. Every breakdown became another headline. Local news stations featured frustrated owners. Investigative reporters documented patterns of failure. Consumer Reports issued warnings. Automotive magazines published critical analyses. Every failed engine became another reason for customers to avoid diesel-powered American cars. What should have been GM's technological breakthrough was turning into a public relations nightmare, and the nightmare was only getting worse. By the early 1980s, warranty claims were piling up. Dealership service departments were overwhelmed. Mechanics worked overtime replacing engines. Replacement engines were being installed at alarming rates. Some dealers reported replacing the same engine multiple times in a single vehicle. One engine would fail, get replaced under warranty. The replacement would fail. Another replacement. Some estimates suggested warranty costs reached hundreds of millions of dollars. The financial impact was staggering. Executives who once celebrated the diesel program were now trying to contain the damage. Internal memos grew increasingly desperate. Finger-pointing intensified, blame shifted constantly. The engineers who had raised concerns early in the program said nothing. They didn't need to. Their warnings had been documented. GM engineers rushed to improve reliability. Cylinder head fasteners were upgraded. Torque specifications changed. Gasket materials improved. Fuel system improvements were introduced. Water separators became standard equipment. Improved fuel filtration was added. Block casting processes were refined. Various running changes attempted to address weaknesses. Later engines were significantly better than early examples. Some 1981 and 1982 engines actually proved reasonably reliable, but the damage had already been done. Public trust is difficult to earn and almost impossible to recover once lost. By 1981 and 1982, the Oldsmobile Diesel V8 had become synonymous with failure in the minds of many consumers. The name itself became a punchline. Comedians joked about it. Late-night talk shows mocked it. Customers who had once embraced diesel technology began abandoning it entirely. Used car values collapsed. A diesel-equipped Oldsmobile might sell for thousands less than an identical gasoline model, sometimes $5,000 less, sometimes more. Dealers struggled to sell inventory. New diesel-equipped cars sat on lots. Incentives didn't help. Price cuts didn't matter. Some dealerships refused to accept diesel-equipped trade-ins. The cars were worthless. Some owners converted their diesel cars back to gasoline power just to avoid future headaches. Conversion kits became a cottage industry. Specialty shops advertised diesel to gasoline swaps. Small businesses thrived on GM's failure. The irony was painful, because diesel technology itself wasn't the problem. Mercedes-Benz continued building durable diesel passenger cars. Their engines ran 500,000 miles. European manufacturers kept refining the concept. Peugeot diesels were popular in Europe. Volkswagen improved their designs. BMW introduced diesel models. The problem was execution. GM had attempted to save time and money by adapting an existing gasoline architecture rather than developing a purpose-built diesel from the ground up. That decision haunted the program from the beginning. Every shortcut had consequences. Every compromise extracted a price. Eventually, production declined. Consumer demand evaporated. Orders stopped coming. The diesel dream that once looked like the future quietly faded away, but the legacy remained. For decades afterward, many American buyers associated passenger car diesels with breakdowns and expensive repairs. Even when Volkswagen introduced modern TDI engines with remarkable reliability and efficiency, many customers remained skeptical. Even when Mercedes continued proving diesel durability, the American market stayed cautious. Even when modern diesel technology became dramatically better, the stigma remained. The ghost of the Oldsmobile Diesel haunted every diesel introduction for 30 years. In many ways, the Oldsmobile Diesel V8 didn't just fail as an engine, it failed as an ambassador. It poisoned an entire market segment. An entire generation of American buyers learned to fear the diesel option, and that's what makes this story so fascinating. The engine actually delivered what it promised in some areas. Fuel economy improved. Operating costs dropped when things worked properly. The concept itself was sound. Diesel passenger cars made sense, but engineering shortcuts, quality control challenges, and relentless corporate pressure transformed a promising idea into a cautionary tale. The Oldsmobile Diesel V8 broke nearly every rule that experienced diesel engineers understood. It ignored decades of institutional knowledge. It prioritized speed over thoroughness. It chose cost-cutting over proper development. And in the end, it paid the price. Not because the dream was impossible, but because the execution wasn't ready, because accountants made engineering decisions, because deadlines mattered more than durability testing, because short-term thinking dominated long-term planning, because pressure from above overruled caution from below. Today, surviving examples have become strange automotive artifacts. Collectors occasionally restore them. Museums display them as historical curiosities. They represent a moment when Detroit desperately tried to reinvent itself. A moment when one company gambled its reputation on a technology it didn't fully understand. A moment when pressure and panic produced disaster. And a reminder that in engineering, there are no shortcuts. Physics always collects the bill. Compromise always extracts its cost. The market always reveals the truth. If you enjoyed this story, let me know in the comments which forgotten engine disaster you'd like to see next. And make sure to subscribe so you don't miss the next deep dive into the machines that changed automotive history for better or worse.